All right, this is the second page, starting with number 7. Here it says to given the graph, identify the domain, range, and behavior, and whether it's growth or decay. So first of all, it's good to identify the asymptotes. Like this one looks like it has a vertical asymptote at 1, and this one looks like it has a horizontal asymptote at -2. So you need to be able to see those in order to do the rest of it. So for domain, the x values, the farthest left it gets. Since this thing is curving downwards, that means the furthest left it's going to get is this asymptote, which is at 1. And then the furthest right it's going to go is this arrow right over here towards infinity. That is a terrible infinity sign. I will try again. Boom. Since you never reach infinity, it will be a parenthesis. And since this is an asymptote, you never reach the asymptote, so it's also a parenthesis. And these ones are always going to have parentheses because you never reach an asymptote and it will go towards an infinity. That's going to be true of domain and range for all of these because there's going to be an asymptote, asymptote. Range is the y values, so you go down and it looks like it goes down forever to negative infinity. And then you go up, and it goes up forever to positive infinity. So if you want to do interval notation, that's the answer. You could also use the symbol for all real numbers. It's up to you. Boom. For the end behavior, it is asking for the x values as well as the y values, because with polynomials and stuff, this will always be negative infinity to positive infinity. But here, it's not necessarily true. As you can see, this x is not going to negative infinity. It's not going left forever. The furthest left it gets is 1, meaning x approaches 1 on the left side. And as you are going down, as you are going towards 1, it is pointing down. And since it is pointing down, that is negative infinity. Whereas on this side, it is going towards the right. And going right is positive infinity. It is also pointing upwards. Since it is pointing upwards, it is positive infinity. So pointing up, so positive infinity. Pointing down, so negative infinity. All right. For the next one, the domain. This goes left, it goes right. So this is going to be all real numbers. Or if you wanted the negative infinity to infinity thing, either is good. Range, down, it goes down forever, so negative infinity. And up, it goes up, it goes up, it goes up until the asymptote. It does not go up forever, it does not go down forever, it is going over, and it is going over at the number -2. As I said earlier, always parentheses. For the end behavior, if you look on the left, it is going left forever, which means this will be negative infinity. And as it is going left, you ask yourself, is it going up, is it going down, or is it going over? This is not going up because of the asymptote. It's obviously not going down. It's going over. So it is going over at the number -2. And finally over here, on the other side right here, this is going towards the right. So this does go to positive infinity. And then you once again ask yourself, is it pointing up, down, or over? And this one is pointing down. Since it is pointing down, it is negative infinity. Okay. Okay. So next problem. Graph the following and say how they relate. I'm going to do the exponential first because it's easier. Make an XY table. In this table, start with whatever makes the exponent 0. So in this case, 0 would make the exponent 0. So 0 will be my middle value. After that, just do 1 above and 1 below. It'll make things easier. If you plug these numbers in, 0, 2 to the 0 is equal to 1, because anything to the 0 is 1. 2 to the first, so plugging in 1. 2 to the first, well, anything to the first is itself, so 2. and then plugging in -1 to the negative first. Negative exponents make things fractions, so that's going to be a half. So that's my table of values. The other thing I need is the asymptote. Since there's no number over here, the asymptote's just going to be at 0. And since this is exponential, it is going to be a horizontal asymptote at y = 0. So horizontal asymptote at y = 0. We got -1 and a half, 0, 1, and 1, 2. So it's looking like this, so it's going to look like this. Boom. Okay. For the logarithmic question, the easiest way to do logarithmic questions is to rewrite it as an exponential. So you have to solve for x. There's no number out here, so you don't have to like add or subtract anything over. Your first step will be to exponentiate. You get rid of the log. The questions I'm going to be asking you in this video and every other video after this is what is the base? Because you always need to know what the base is. So the base is 2. So what base are we going to use? 2. So this is a log 2. We are going to exponentiate with a 2. That way this 2 cancels out that log 2. And this would say 2 to the y is equal to x. Or x equals 2 to the y, whichever. And now you can make an xy table. Just keep in mind that because the way this is written, you need to plug in numbers for y, not for x. So if you plug in 0 again, 0 makes the exponent 0. -1 and 1, this will start to look very familiar because, you know, this is 2 to the y and that was 2 to the x. You get the same numbers when you plug them in. You plug in 0, 2 to the 0 is 1. If you plug in 1, 2 to the first is 2. And if you plug in -1, 2 to the negative first is a half. But since this is a log question, you know, if you set that equal to 0, you just get 0. It has a vertical asymptote at x = 0. So on the previous video, we set this equal to 0 to get the asymptote. You could also, after rewriting it, look here, and you can see it's 0 as well. But I'm going to go ahead and do this. Vertical asymptote at 0. 1/2 -1. 1, 0, and 2, 1. So it's going to look like that a bit, and curve like that, and curve like that. Boom. So graph the following equations on the same grid. Check. Explain how they relate. Well, the thing is, they're complete opposites. These numbers are literally the same, but switched. You know, the x's and the y's switched. And that is the definition of inverse. These two things are opposites, meaning inverse. So I'm going to write down they are inverses. Boom. You can tell because their tables are the same numbers but backwards. You can tell here because it reflects across the main diagonal. That's a property of inverses. But, you know, inverse means opposite. So the opposite of -1 1/2 is a half -1, etc. There you go. They are inverses. So I have described how they related. Please make sure you read the directions on the test, because you do have to do that kind of thing. And I think that's it for the graphing part. Yes, we finally get into the algebra on the next one. So there you go. See you in probably about 7 seconds. That's usually how long it takes to load the next video and press the start button. Have a good one.